All right, looks like there's some weird stuff going on with the printing, so we've got to fill that in. There's supposed to be a U there. These are ones that we know. Who remembers tan? And then cotangent. Nice. So there's a lot of similarities between them. And something that I noticed is if you line them up in these columns, like if you line up sine, tan, secant, cosine, cotangent, cosecant, this is cosecant U, then the columns kind of share some properties. Might be a helpful way of memorizing them for the test. Does anybody remember secant? Nice. And so then when I look at the next one, these, we notice that in this column they're all negative. So we kind of did that on purpose. And like cotangent and cosecant are there together. Like they come up together, see that? And tan and secant are all together, like they're grouped together. It's maybe a helpful way of memorizing for the test, because you just got to remember it for a little bit and then you can forget it, I guess. Until the exam. Are we okay with this? So all we're doing today, it's great because it's more practice of the same stuff of just taking derivatives, but we've got a few more to do, and we'll see a couple other little tricks. But for the most part, it's more practice of the same kind of thing. But we got to know all 6 derivatives. Go ahead. Don't copy me. See, try it, see if you get it right. Then if you get it wrong, then you can copy the correct answer and you can sort of reflect on your mistakes. So there's my first line. I'm going to tidy it up a little bit. So I want you to watch for a minute. We are going to take up the quiz today and talk about a few other things. And a couple things will come up throughout this lesson, I think, that'll maybe be helpful. But if I examine this, if I go back and I think about this, it's secant U tan U. That part doesn't change. That's the angle. So whatever the angle was in the question is the same angle for both those parts. And then I multiply by the derivative of just the angle. Not any of the other part, just the angle. And I can tidy this up now by taking the 16 and the 1/2. This is like on the quiz where it said simplify, and in the previous units, simplify monomials and negative exponents only. So there's no negative exponents here, but monomials would be like the 1/2 and the 16. We should put together to an 8. This is not the most important part of the process, and I'm not looking to take marks off for it. That's not the point. I'm not trying to, like, Mr. Gardner and I were talking about this, and he made the comment, we don't we're not trying to get them to read our minds. Like, every question is a little bit different. It's hard to know how far you should go, when you should stop. I get that. But something like 16 times a half is 8. That should be pretty straightforward. In general, most of those things should be tied up. If you missed one for some reason, you might get away with that. But in general, something like that should be tied up. I wouldn't put it as all 16 over 2. Like, why would we do that, right? We do want to simplify things to some extent. Okay. That being said, some of the questions get kind of wonky, and it can be harder to see. But on the quiz, there were times where people didn't clean up monomials where I feel like they probably should have. Careful of this one. It's not like, where are the brackets? They're here. Okay, that's the 5th root of x, not cosecant to the 5th. If you were looking at a test and you couldn't tell because the font was small, or I would be curious to type this out the other way and see how similar they look, actually. They would look fairly similar. But if you weren't sure, ask, because that's, again, not probably the point of a question like this, is that you can read the font of the computer. So again, this is just cosecant u. So derivative of cosecant is negative cosecant times cotan. So I do that, negative cosecant times cotan. And that's just u. So that's like the angle doesn't change. The 5th root of x is the same as what? How do we think about that? You could rewrite it if you want. Yeah, x to the 1 over 5, right? Very good. So you could rewrite it there, and some people do like to do that. And now this part here at the end is going to be the derivative of x to the 1 over 5, which is, I multiply by the exponent, and then I have my x, and then I subtract 1 from the exponent. So that's negative 4 over 5. And again, that's a negative exponent, so that's got to be tidied up. And I'll take the 1/5 kind of out front, although the 5 is going to end up on the bottom. So it's going to be negative cosecant 5th root of x cotan 5th root of x. Use brackets to clean things up in an easy way, and then you don't have to worry as much about where things belong. Okay, and so the 5 is on the bottom, and then this is the 5th root of x to the 4th. Whether the 4 is in the square root or outside the square root doesn't really matter. Order, that won't matter. But it's probably easier to write it that way. Okay, see what I mean? More of the same, but we've got some of the new ones in there. Okay, try this one. Careful, this one does have an exponent. This was one that did trip some people up on the quiz. We're still working on this, in other words. This is the hard one, where how do you handle when it's got an exponent? So take a look at what I did over here. What if this was a cubed? Then it'd be 3a squared times the derivative of a, whatever a is. So if a was a function, if there was something that you could do to actually take the derivative of a, then you'd do that, right? So how do I do it the same way here? So I take the 3 out front, and then it's like a squared. What is a? It's cosecant of 3x squared. Now, if you want to watch, how do we typically write this? You can do it this way. Again, as I've said, rewrite it with the exponent on the outside in big square brackets like that if you have to, until you're getting these right consistently. The only way you know you're getting right consistently is when you're doing the practice and checking your answers, that kind of thing, right? But usually we write it like this. So that's fine to do that. Times the derivative of a. Not the derivative of a squared. Not the derivative of a cubed, just the derivative of a. So the derivative of just this, cosecant 3x squared. That's a. So this part's going here. What's the derivative of cosecant? We just did that up here, didn't we? Didn't we do a cosecant? So there it is again. Negative cosecant times cotangent. So negative cosecant of the same angle. No exponents on the cosecant part. Cotan of the same angle. And now what do we have to add in as well? Yeah, 6x, because that's the derivative of the angle. That's the extra part that we do at the end, the derivative of the angle. And just once, I could see people like, oh, there's 2 angles in here now, so do I do it twice? No. No. We got some cleaning up to do here. I've got the 6x, I've got the 3, I've got the negative, so that's all of the monomial part that I can put together. And there's one other little interesting thing that happens in this case. So again, this would be like for that last half mark on a question, noticing. Yeah, you can, can't you? It's cosecant squared and cosecant of the same angle. So this ends up being cosecant cubed of 3x squared times cotangent of 3x squared. That's exactly right. And this is where trigonometry is different from like polynomials, where in polynomials, the exponent is always decreasing. And in this case, it didn't. Like if I was going to take the derivative of this to take the second derivative, it's got the same function in it. The exact same function from the first part. So it would have the derivative of that, which is itself again, it would be strange, but anyway. And that happens in trigonometry, for sure. All right, let's keep going. Again, why don't you try this one? So this is another very similar question in that it has an exponent, and now this time is cotangent. And you could picture it like this. There's the angle. It's 3x plus 1 all to the 5th, right? That exponent of 5 is on just the angle part, and then the 4 is the exponent of the whole thing. Thank you. So we got this part to start. This is just the exponent. 4 cotangent cubed times the same angle. And now the derivative of cotangent is just in general, not the whole part, but negative cosecant squared. Good. Of the same angle. So that's 3x plus 1 all to the 5th. And then times the derivative of the angle. And this is tricky because the derivative of the angle, this is the part that people would probably miss coming up in a second here. 5 times 3x plus 1 to the 4. What am I missing? Yeah. Times the derivative of what's inside again. Right? The derivative of what's inside there. A lot of little things to think about. And then tidying it up, let's see. I've got 4 and 5 and 3, I think, are the only monomials that we have there. So that's 20 times 3, which is 60, and I've got a negative. And then the order that you do this is not like written in stone. There's no rule for it, but I'm going to write the binomial there next. So 3x plus 1 to the 4th times cotangent cubed of the angle times cosecant squared of the angle. I think I got everything. Yeah, now take the second derivative. Oh my gosh. Now sketch it. Okay, everybody okay? Let's try this one. I hope you notice this one's a product rule. But it's a lot simpler because the angle is just x, right? So there's not all of the extra stuff. Okay, so it looks something like this, I think. The derivative of the first thing times the second thing plus the first thing times the derivative of the second thing. Tidy this up a little bit. And it's factorable. I noticed that. There's no rule that you have to factor it, but why don't you try to factor it? It's always good practice. just take out an x squared. Everybody okay so far? Any questions? Anybody wondering anything? Okay, let's try another one. What did you notice when you did the first line of that one? So it's quotient rule. Derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Did you notice that it's all cosecants and cotangents? That jump out at anybody? Make you wonder anything about this one when we start to tidy it up? So negative cosecant cubed x minus, no, plus, so I could flip those around, but I don't have to. Cosecant x cotangent squared x over cosecant squared x. And if you want to just watch, I can get rid of some of the cosecants because I can factor it out of the top, and I got one with the bottom. And I'm going to flip things around a little bit here, so I'm going to get the cotangent squared x over here. Just while I'm thinking about it, we're going to take up the quiz, so hopefully we'll look at it there. But sometimes in these, it's just an error in like rushing where we forget to write the angle x. Like I could see not writing the x there because we've got all these cosecants and sines, and when the angle is bigger, maybe you're more likely to write it, but when it's just an x, you forget. But that's a really big deal in mathematics at this level, that if you just wrote like cosecant cotangent, that's really meaningless, right? It's got to be of something, and we talked about this before, but you got to have the angle in there. So that could be something you check at the end of a test and go through and make sure you haven't forgotten your x's for the angles in there anywhere. Okay, so where was I? Now I lost my place. Minus cosecant, so I've taken one of these out, squared over just one cosecant x. And I'll give you a little tip. If you really knew your Pythagorean identities, you could take this a step further and do something really nice with it, but I would expect that it's using one that most people don't know off the top of their heads. But I could also, with the cotangent and the cosecant, if you know your identities around those pretty well, you'd notice that they have some commonalities, and there's a lot that you can do with this one. But what if instead of all that, let me show you this trick. So if y is cotangent x over cosecant x, okay, what is cotangent? Yep. Cos over sine. Divided by what's cosecant? 1 over sine. So that's cos over sine times sine. So y prime is negative sine x. That was easier. It turns out this is negative sine x. And with a few steps, either coming up with a common denominator or using a lesser known Pythagorean identity, you could get the same thing. I don't think you'd be expected to know that for a test, if anybody's wondering that, but it's worthwhile, especially if you're going through, again, your homework and you notice that you get a different answer, like, it's worthwhile thinking about that as an identity. Taking a moment and thinking about cotangent and cosecant, is there a way to simplify that before I take the derivative? I think that's a worthwhile thing to do. And just quickly off in the side on scrap paper or something like, can I make this really simple? If you can't quickly make it simple, like as simple as cos x, then it's probably not worth it. But if you can, you can. Okay, we're just going to do a couple of implicit differentiation questions. This one's pretty simple, I think. You can give it a try when we're done. So on the left side, the derivative of sine is cosine times the derivative of the angle, which is just 4, so that part's pretty easy. And the derivative on the other side, the derivative of cosecant is negative cosecant times cotan. Times the derivative of the angle. So this is the part where I would want to be careful. And the derivative of the angle is going to be 5 dy by dx. Solving for dy by dx. Pretty straightforward. I can just divide by everything. So the rest of it's already pretty much cleaned up. And nothing you can do there. Remember, it's really, really important. I don't want anybody getting carried away with the kind of little identity tricks that we've done here and there. And I noticed that the angles are different. This is cos of 4x. This is cotangent of 5y. Nothing you can do there. Right? One more. if you got this far, you might notice something interesting happens here that I'm not sure we've seen, or not many times. What's happening here? Yeah, it's a product rule in the angle. All kinds of things can happen, right? So the derivative of y squared, remember when it's added, it's isolated, you just take the derivative of it by itself, so it's 2y, but don't forget, whenever you're dealing with a y, you got the dy by dx in there. Okay? Plus, and so the derivative of cotangent, there's no exponent, it's just cotangent to the 1. So I just take that derivative directly, which is negative cosecant squared of the angle 4xy times the derivative of the angle. So I'm going to put big square brackets. And it's 4x times y. Right? P is 4x, Q is y. So the derivative of the first thing is just 4 times the second thing plus the first thing, 4x, times the derivative of the second thing, which is y. So it's just dy by dx. Equals the derivative of 0 is 0. Now the order in which you like to do this is up to you. Again, it probably takes a few times going through it to practice and really make sure you've done it on your own a few times. And I think there were a few mistakes around this on the quiz. Just distributing. This has to be distributed to both of these, right? So I've got 4y cosecant squared 4xy minus 4x cosecant squared 4xy times dy by dx. Oops. This step here is where I have expanded the brackets. A lot of the time with these implicit derivative questions, that ends up happening. Here I just moved the other junk to one side, so I've got my dy by dx's together. Factor out the dy by dx. That's what I've done here. And then divide. I think there are stages to being successful at this. The first stage is just being familiar with the steps. I mean, taking the derivative itself can be tricky because there are so many layers to it if you have the exponents and a complicated angle or anything like that, right? Or the product rule or whatever it is. So there's that part. But then there's maybe expanding, because you've got like dy by dx in brackets, you got to do that expansion, then you got to get them by itself, then you got to factor, then you got to divide. But knowing all those steps, you get pretty familiar with those fairly quickly. But then it's just a matter of, so that's sort of partway successful, knowing that those are the steps involved. But then there's actually doing it correctly and getting every algebra and not dropping a negative. That's the next level of success, right? Because it's even if you know what to do, actually doing it successfully can still be tricky. And so this is what I got so far. And I do notice that I could factor out a 2 there. You know what? I'm not even, well, maybe we will. Just to be perfect. But so that's 2y. But this is the kind of thing where, to me, this isn't as important of a step. To notice. There you have it. Any questions?